Alright guys, welcome to lesson 2.2, and it's actually one of my favorite lessons. It's kind of a neat little lesson here where we leverage some information from 2.1 and then find out we can use that for angles in the second quadrant, third quadrant, and fourth quadrant. And so here are the basic idea here. And you had a discovery activity yesterday, or today, and then you're watching it tonight. But basically, you have to memorize a chart with 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 in it. We want to now use that or leverage that information to find about angles in the other three quadrants. So once we've got this chart memorized for 30, 45, 60, and 0 and 90, could we use it to find angles bigger than 90? So angles in the second, third, and fourth quadrants. And what you should have noticed yesterday or today on that discovery activity is if you had a 30-degree angle, the sine of 30 was the same as the sine of 150, the numerical value, was the same as the sine of 210, which was the same as the sine of 330. And again, we're disregarding the plus or minus signs. Guys, don't worry about the plus or minus signs. A smart trig class will give us the plus or minus signs, but the numerical value of those four trig functions was the same. And that would also be true for the cosine, that'd be true for the tangent, and of course that'd be then true for the reciprocal functions. And let's just look at that very, very quickly just to make sure I'm not making these things up. Make sure your mode is in degrees. And let's try the sine of 30. And you should have found 0.5. Try the sine of 150. You should have found it's 0.5. You should try the sine of 210. And you'll find 0.5. Oh wait, negative 0.5. We're ignoring the negative sign. It's okay. And let's find the sine of 330. And look at that, negative 0.5. They all come out to be the same numerical value. The plus or minus we will get to. All right. And like I say, this works for cosines and tangents as well. If you graph that, I didn't give myself a lot of space. Let's put it over here. What would those four angles look like? Well, you came up 30 degrees. That's maybe a little more than 30. And over here's your 150, and here's your 210, and here's your 330. And what you start to realize is they're all, this is 30 degrees, and the 150 is if you came up here, if you backed up 30 degrees, or here if you went 30 this way, they're all 30 degrees. All four of these angles are 30 degrees from the x-axis. And that's going to be our key idea to this. But you notice once you sketch it, you get this nice symmetrical drawing. And coming away from the x-axis, they all have the same degree measure. It might be a positive 30, a negative 30, but they're all 30 degrees from the x-axis. So that gives us our key idea here. Oops, I guess the question is here. So what do these four angles have in common? And there's more than one answer, but this is the most useful answer. You could say, aren't they the same measure, same degree measure from the y-axis? They are. It's just not very useful. The useful answer is they're the same distance or the same angle from the x-axis. And so the angle that's always between 0 and 9, oh, here it is. But we've got here, so that 30-degree angle, that measure from the x-axis is called the reference angle. And so the reference angle is going to be an acute angle between where your angle stops and then down to the x-axis. Every now and then somebody gets fooled and they measure it over to the y-axis. Don't do that. Measure it down to the x-axis. That's your reference angle. So it's an acute angle, meaning between 0 and 90 degrees. A reference angle is always between 0 and 90. And then it will turn out that if you have the same reference angle, then you have the same trig function. And you'll see on the fourth slide when we do that how this works out. But the reference angle then is the distance to the angular distance to the x-axis. So if I gave you an angle, could you find the reference angle? And maybe at first we'll sketch these out and then later on you'll say, oh, I got it. So 104 degrees, you open up 90, you come a little past. So somewhere over here is 104 degrees. Well, how far is that to the x-axis? And you always have to give an answer between 0 and 90. The reference angle is an acute angle. Well, it looks like 180 minus 104. 180 minus 104. The reference angle would be 76 degrees. So down to the x-axis, right there, would be another 76 degrees. Okay, and again, the easiest way, I could give you a formula, but it varies depending if you're in the second quadrant, the third quadrant, or the fourth quadrant. You don't really need 3 formulas. The easiest way is just to think through this. So let's try a third quadrant angle. 221. So we rotate around. Here we're at 90, here at 180. We come down to 221. Some kind of an angle here, 221 degrees. We shot past the x-axis, so I go 221. I take off the 180 degrees because that's the negative x-axis, and what's left? 41 degrees. So notice in these first two calculations we used 180 degrees in our calculations. Okay? Think that'll work in the fourth quadrant? It won't. Let's rotate around 341 degrees. So I come around 90, 180, 270. Somewhere over here, 341 degrees. Man, you almost made it all the way around to 360. So use that 360 in your calculation. What's 360 minus 341? 19 degrees. Okay? So you're going to use 180 degrees in your calculations if you're in the second or third quadrant. You'll use 360 degrees in your calculation in your fourth quadrant. You will never use a 90 degrees or 270 degrees in any of these calculations. And if you find yourself using a 90 or 270, just understand you're doing it incorrectly. All right, so always you're going to use a 180 or a 360 because that's the x-axis. All right, 19 degrees. Oh, wait. That is between 0 and 90. That is your reference angle. Good enough. Negative 146. Well, let's use 180 in our calculation. I'll add that on. And it looks like a 34 degrees. So it's always between 0 and 90. Negative answers are not allowed. Negative 70? Just said negatives aren't allowed. Guys, you backed up 70 degrees from the x-axis. What's your reference angle? Are you thinking 70 degrees? You should be. You backed up. What's the distance to your x-axis? 70. You backed up 70. What about 750? Well, first of all, it's too big. Take off a 360. Take off another 360. Well, actually, we'll do that one at a time. It's a little fast for you. Sorry. Take off a 360. That's one rotation. What's left? 390 degrees. Still too big. Take off another 360. What's left? 30 degrees. That's between 0 and 90. That is your reference angle. All right. 359. Oh, almost a full rotation. As a matter of fact, I'm 1 degree away from a full rotation. And again, we're using 180 in our calculations or 360 in your calculations. Okay, so that's the reference angle concept. And now we're going to leverage that with the information that you should have in your chart with the 30, 45, and 60 that's in your chart. And now they give you an angle that's not 30, 45, or 60. They give you 135 degrees. You immediately want to find the reference angle. And I go 180. It's the second quadrant. So 180 minus 135. My reference angle is 45 degrees. So guys, what's the sine of 135 degrees? It's the same as the sine of 45 degrees. Look that up in your chart. What's the sine of 45 degrees? Square root of 2 over 2. What's the cosine of 135 degrees? Same as the cosine of 45 degrees. Square root of 2 over 2. And now what's the tangent of 135 degrees? Same as the cosine, same as the tangent of 45 degrees. It is 1. Okay, hopefully one part of this is bothering you. And that part, because you are part of a smart trig class, is you're saying, wait a minute. I am in the second quadrant. 135 degrees puts me in the second quadrant. I know from chapter 1, a smart trig class, I know the sine is positive. So now we'll find we've been ignoring the signs till now. So the square root of 2 over 2 is positive. The cosine should be negative, and the tangent should be negative. So you ignore it till the very, very end, and then come back to right there, a smart trig class, and get your plus or minus signs. So I've got those three. I'll let you guys do the reciprocal values. You just take, literally, you take the reciprocals. All right, 240. What's your reference angle? I think our reference angle looks like 60 degrees. That sound right? Because I take off 180. So what's the sine of 240 degrees? Same as the sine of 60 degrees. Square root of 3 over 2. What's the cosine? 240 degrees? Same as the cosine of 60 degrees. 1/2. So it's nice if you have that chart memorized, and all you need in that chart is 0, 30, 45, 60, and 90. What's the tangent of 240 degrees? Same as the tangent of 60 degrees. Square root of 3. Guys, you're in the third quadrant. A smart trig. Third quadrant right there. Tangent is positive. The other two trig functions are negative. So don't forget that at the very, very end. That's kind of a common mistake, is people forget the plus or minus signs. 330, reference angle, 30 degrees. What's the sine of 330 degrees? Same as the sine of 30 degrees. 1/2. What's the cosine of 330 degrees? Same as the cosine of 30. Square root of 3 over 2. And the tangent of 330 degrees is the same as the tangent of 30 degrees. Square root of 3 all over 3. A smart trig class. 330 is the fourth quadrant. Cosine is positive. Put a negative right there. A negative right there. You are done. Kind of a neat way to leverage your information. Okay, 570, too big. Take off 360. I'm down to 210. What's my reference angle? 30 degrees. Wait a minute. We just did that problem. Except 210, right here where the reference angle is 30 degrees. This one right here. Except 210 puts us in the third quadrant. So I can take these exact same values right here because the reference angle is the same. So I've got my sine is 1/2. My cosine is root 3 over 2. And my tangent is root 3 over 3. And I remember I'm in the third quadrant. A smart trig. Tangent's positive, sine is negative, cosine is negative. Done. So what a great fact to have with these reference angles. You can now find angles in the second quadrant, third quadrant, and fourth quadrant. So, with a little bit of information, you've just kind of quadrupled the angles that you can find. So that completes the video.